Hello guys, Merry Christmas and all. And I just want to show you this really cool equation. So, this equation is linear. Linear, okay? Nothing is raised to a power really. The dependent variable isn't. But this equation is linear, completely linear. Okay? Let's add a y squared term. Now it's a Bernoulli equation. Because the y squared term makes it so that the definition of a linear differential equation no longer fits this particular equation that we have at hand. So the y squared that I just added screwed everything up, and I'm going to tell you how to do it now. So this wouldn't work without us using Bernoulli equations or some other methods that we would use later on in the class. But I'm going to teach you how to use Bernoulli equations. So, or do them. So, you got y squared over y squared to cancel out the y squared on the right. You get x times 1 over y squared dy dx, because that's what a y prime is. It becomes a dy dx. It's just the same thing. It's just saying the same thing, essentially. X squared e to the x, because the y squared's canceled out. And we can notice something very interesting here. You got a 1 over y and a 1 over y squared. If we do this substitution of u is equal to 1 over y, okay? And then we dx it. Take the derivative of both sides. You get du dx is equal to, well, this is essentially the same as y to the negative 1. So if you take the derivative, you get negative y to the negative 2 dy dx, because this is the derivative of y with respect to x, and that's how you do implicit differentiation, which we should have learned in Calculus 1. So, you get negative y to the negative 2 dy dx. If we move the negative to the other side, negative du dx is equal to, we're going to rewrite this as 1 over y squared dy dx. We're going to notice that this over here matches this over here. Okay? And that this over here, we already substituted it, matches this over here. We can rewrite this whole thing in this very neat method. Negative du dx, because the negative was moved to the other side, x plus u is equal to x squared e to the x. Very neat. If we go ahead and divide by negative x rather, this will cancel out, become negative x e to the x. This will all cancel out and become du dx minus 1 over x u is equal to negative x e to the x. And now, we can use something called the method of integrating factors, whatever you want to call it. Let's set p of x is equal to negative 1 over x, right? And if we integrate p of x with respect to x, we're going to get negative ln x, because the integral of negative 1 over x dx is equal to that. And we don't need to worry about plus c's. We could just say c is equal to 0. And to get our integrating factor, we raise e to the integral of p to the x is equal to our integrating factor. So, e to the negative ln x is equal to absolute value of x to the negative 1, because this is equivalent to e to the ln x to the negative 1. And, well, sorry, not exactly that, but rather like that. And in that case, we could just give an interval of 0 to infinity, and we could just go ahead and say it's x to the negative 1 to make our life easier. So working on the interval 0 to infinity, we can use this integration factor on this interval. And this integration factor can be multiplied. So in this case, if we multiply x to the negative 1 by du dx minus 1 over x u is equal to negative x e to the x, we're going to get 1 over x du dx minus 1 over x squared u is equal to negative e to the x. Should be quite simple to see that what we have over here is the product rule. We got the product rule here. And what we can do is infer a pattern that's going on. This is equivalent to d dx of 1 over x times u, which is equal to negative e to the x. You guys don't believe me? We'll do it on the side. Side problem. So, what is the product rule? F prime of x, g of x, plus g prime of x, f of x. Quite simple, right? So, what's f of x is equal to 1 over x, g of x is equal to u. Okay? F prime of x is equal to, well, it's x to the negative 1, so it's going to be negative 1 over x squared. And g prime of x is simply du dx, because we're doing the whole thing with respect to x. So, using this formula, we get, what do you get, guys? We get negative 1 over x squared u plus, negative 1 over x squared u plus 1 over x du dx. I see a similarity. So, this works. And what we can do now, take the integral, both with respect to x. Let me move the bar. That's going to cancel out with the integral, because integral of a derivative, you're just going to get the derivative, or, you know, it's just going to cancel out. You're just going to get 1 or whatever. So, those two cancel out. Get u over x, quite simply. And the integral of a exponential is the same thing. So, it's negative e to the x plus c. We need a c this time around. And now, we go back. What was our u? Our u was y to the negative 1. So, it is 1 over y times 1 over x is equal to negative e to the x plus c. And, well, instead of doing that, we could have just done this. Times x, and that would be u is equal to negative x e to the x plus c x 1 over y from the substitution earlier is equal to negative x e to the x plus cx. Now, this is technically correct, but if we want to get an exponential form, we have to divide everything by 1, so it becomes y is equal to 1 over negative x e to the x plus cx. And that's why Bernoullis are so fucking cool. Have a Merry Christmas, everyone. I hope you enjoyed this video. Sorry the quality's probably garbage, but I'm just really happy that I got through the 3rd attempt of this. Be safe, everyone. Take care of yourself. You only got one life, people. And do the things that you enjoy the most. Speaking of which, I really do enjoy Bernoulli Equations. Peace, and Merry Christmas and a Happy New Year.